All right, everybody. So for this first lesson, we're just going to do a review of linear equations. Um, so this shouldn't be anything brand new to everybody in SM3. You should already be pretty familiar with this, but for the first week, as we settle into how things are going to work, we're going to just briefly cover review of linear equations. So before we get into a review, I want to make sure that everybody understands the most basic definition of what a function is, because pretty much for this whole year, we're going to be talking about functions. And it's very important that we understand exactly what a function is. So I have a definition here. A function is a relation from a set of inputs to a set of possible outputs, where each input is related to exactly one output. So what does that mean? We'll break that down in just a second. And before we get into breaking that down, I just want to point out the most basic function that we know of is the linear function. That's why we're going to review it. And so right here, I have just the parent function of our linear equation. That is a parent function. But whenever we do any sort of transformations to this functions, to the linear function, it looks more like f of x equals mx plus b. So transformations meaning depending on what m is, well, you can have a negative slope or a more steep or more shallow slope. And depending on what b is, you have a y-intercept, right? So let's just say as we cover this example, let's say that f of x is equal to 2x plus 1. So let's go back to our definition. It talks about inputs and outputs. So let's go ahead and highlight these very important words. Let's say outputs we'll label as blue, inputs we'll label as orange for the sake of tint view. So first start with inputs. Let's go with outputs. What are output values? So when you see f of x, this is going to be your y value, right? We often use y and f of x interchangeably. So this is your output value. And we also refer to it as the dependent variable. And we'll talk about why we call it the dependent variable. And then we have our input value, which is x. So x is our input value, or we call it the independent variable. So let's go back to our example that we were talking about. F of x equals 2x plus 1. Now let's say we wanted to graph this, but before we graph it, let's go ahead and make a table. All right, so here we're going to put x, and over here we're going to put f of x. So we call x the input value because that is the value that we put into the equation in order to get a value for f of x. That is our output. So for instance, let's say we want to find the value when x is negative 2. So we say when x is negative 2, what is f of x? Well, let's input negative 2 into our function. So f of, we said negative 2, is equal to 2 times negative 2 plus 1. So what is that output? Well, 2 times negative 2 is negative 4. And then we add 1. That's going to be negative 3, right? So f of x is equal to negative 3 when x is negative 2. Thus our inputs right here and our outputs right here. So let's go ahead and graph that. When x is negative 2, our y value is negative 3. Right there. Okay, now let's go ahead and graph another point. 0 is often a pretty easy point to graph, right? So let's input 0 into our function. So f of 0 is equal to 2 times by 0 plus 1. Well, 2 times by 0, that's just 0. And then we're just left with 1. So when x is 0, our y is 1 right there. Now, we could already tell that when x is 0, what y is equal to from our function, right? Because this is in a slope-intercept form, where b, this is b, that's our y-intercept. And sure enough, whenever we put 0 into our function, we get 1. Now let's go ahead and draw our line that we have here. There we go. Just like that. That's what our linear line looks like. Now remember what m is equal to. M is our slope, right? And slope is equal to our rise over our run. And we know our rise over our run is equal to 2 because that's what m is. And we can write that as a fraction, 2 over 1. So our rise is 2 and our run is 1. So you can see as we go from -2 to -1 to 0, for each one, we're going up 2 and over 1, up 2 and over 1. Okay, so I hope everyone understands how a function works from an input to an output. And let's highlight one more important part about this definition, is that each input is related to exactly one output. So each input is related to exactly one output. So I can't have the same input, let's say 0 is also equal to 3. Well, there is already an output value for 0, for our input value 0. So we can't have 0 also be 3, because you can't have two output values for one input value. That is not a function. So make sure that you are aware of that too. And so just to kind of go over what independent and dependent variable is, we say that the x is independent variable and y is dependent variable. Y is the dependent variable because if I asked you what is f of x equal, well, you would have to ask me, well, that depends on what x is equal to, right? Because depending on what x is, y can be an infinite, you can have infinite answers for that. So that's why we call them the independent variable and the dependent variable. Okay, now we're just going to go over some examples, and you can find these in the textbook prior to the exercises in 2.3. So on page 56 of your textbook, you'll see a graph. You'll see a story of a graph where it describes how fast an asteroid travels. And you'll see that we have on the x-axis, we have our time in seconds. So our x values, our input values are time, and our output values will be miles. And it gives you a point on that graph. And I believe the point that it gives you is at 524. So let's go ahead at 524. Let's make our point. And it says it's a linear function and it passes through at 524. So let's go ahead and draw that in there. And this right here, 524. Sorry if you can't read that, but 524. So let's write an equation for this line knowing a point. So let's try and write it in slope-intercept form. Slope-intercept form, of course, I'll write it up here. F of x is equal to mx plus b. So we need to find m and b. So what is our slope? Well, we talked about it earlier. Our slope is equal to the rise over run. So we already have a point. So what we can do from this point is find the rise from the point of origin and our run. So the point of origin being 0, 0. So what is the rise right here? Well, it's pretty easy. passes through the point 2, 4, the y value 24. So we know that the rise is 24. And then this is going to be our run. Sorry. This is our run value. This is our x value. And we know that we go over 5. That's our run. So pretty simple and straightforward how we find our slope. Our slope is 24 over 5. And if possible, you should always try to simplify if it is a ratio or a fraction like that. But in this case, we can't simplify, and that's just fine. Now we need to find our y-intercept. Well, it's pretty simple because there is no y-intercept. It just passes through the point of origin at 0, 0. So b is equal to 0. Now let's go ahead and write out our equation. So f of x is equal to, well, m we said was 24 over 5, x plus 0. So I'm not going to write that in. We don't have a y-intercept. So there we go. That's our function right there. Now, it asks us in the book, how long does it take the asteroid to travel 17,200 miles? So now this asteroid is traveling pretty fast. If at 5 seconds, it's already going 24 miles. So this asteroid is hauling. So let's go ahead. If we want to find out how long it takes, how long does it take when it travels this many miles? Well, again, we don't know. We're trying to find our x value after it's traveled so many miles. So this is our y value, right? So let's plug that into our function. And we're not going to plug this value into x because x represents time, and in this case, f of x is miles. So we're going to write that as 17,200 is equal to 24 over 5x, because we're trying to find how long. We're not trying to find the miles. Well, using basic algebra skills, if we multiply both sides by 5 over 24, we can get x all by itself. Sorry, 5 over 24. So those would cancel. So you're left with x on one side. So we have x is equal to 5 over 24 times 17,200. And if we plug that into our calculator, 5 times 17, 2,000, and we divide that by 24. It's going to be 3,000 about, this is going to be an estimate, 3,583 seconds. Always write your units. We are talking about seconds. Okay, now for this last example, this is also from the book on page 57. There's a second problem. And you can read through the context of the problem. I'm just writing out really quickly the numbers that we want from that problem. But this time, you're given x and y values. So we want to find the slope using 2 points from the table. So we have this table, and we're going to use 2 points. So unlike in this question up here, it gave us just 1 point. So let's see. So using 2 points from the table, we're going to find the slope. Well, again, we know m is equal to our rise over our run. Well, to find our rise with 2 points, our 2 points, let's just take these 2 points right here. Let's call this y1, let's call this y2. So our rise, which is always measured in the y direction, is going to be the difference between these two values right here, our two y values. The difference meaning 1,800 minus 1,500. And our run is going to be the difference in the x direction. So the difference between these two. If we want to find the difference, we subtract the two. So if we do that math, 18 minus 1500, well, that should be 300. 125 minus 100, that's going to be 25. 300 divided by 25 should be 12. So that right there is our slope. And now it's asking that we use point slope form. Point slope form, I'll remind you. So point slope form looks like this. Y minus y1 is equal to m multiplied by x minus x1. So to use point slope form, we need a point and the slope to find the y-intercept. Well, we already found the slope and we have a point. You can choose from any of these points over in this table right here. So I'm just going to choose, let's see, let's just go ahead and use this point right here, this first point that we have. So writing in point slope form, y minus y1, our y1 was 1500. Sorry, let me go back and correct this right here. This right here was x1. This right here was x2. This right here is y1. This right here is y2. There we go. And let me go ahead right here. Rise over run is equal to y2 minus y1 divided by x2 minus x1. And that's what we did right there. Okay, so back to our point slope form is equal to, and then our m, which was 12, multiplied by x minus our x1 value, which was 100. Now let's go ahead and break this down and let's put it into, now that we have everything, we can actually change this to slope-intercept form and find our y-intercept. So first, what we need to do is distribute that 12 in there. So y minus 1500 is equal to, well, 12 times x is 12x, and then minus 12 times by 100, it's going to be 1200, like that. To get it into y-intercept form, we need y to be all by itself. So if we add 1500 to both sides, that goes away. So we're left with y on this side, 12x. So negative 1200 plus 1500 is 300. And there you go. Now what is our y-intercept? Well, just by looking at that equation, our y-intercept is equal to 300. And there you go. That's how we use a slope-intercept form and point slope form. Pretty straightforward. So if there's anything that didn't make sense, please go back and watch the video. Make sure you understand this. Again, this is just a review. Most of you should already know this, so it should be pretty straightforward and easy. But if you have any questions, please come to me whenever we have class time, and we'll go over it. All right, thanks, guys.